Hi everyone, Shine Burcha here. I'm the product specialist for IO-Link and IoT at Pepperl+Fuchs. In the previous few videos, we took a deep dive into MQTT and how to configure your IO-Link master ICE2 and ICE3 to connect to a MQTT broker. In this video, I want to introduce Sparkplug, the MQTT specification designed for Industrial Internet of Things, IIoT. The first question that comes to my mind and should come to your mind is, what is Sparkplug? And why should you care about it over the standard or vanilla MQTT? Vanilla MQTT or MQTT is a transportation spec and does not define a fixed standard for topic structure or payload. The payload and topic structure implementation are more of a design choice. In contrast, Sparkplug is a framework built on top of MQTT to a predefined topic structure for industrial data. The payload data is compressed, so more data can be sent for the same bandwidth as compared to standard MQTT. Moreover, it has a predefined payload format. So in case an application is getting developed, you know that different Sparkplug devices are going to provide you the same format for your application. That makes integration much more simpler. So let me take you through the MQTT configuration on our IO-Link master ICE2 to connect to a broker and transmit MQTT but Sparkplug. And moreover, we will see how the topic structure looks like for Sparkplug and how the payload data looks like. And we will see a correlation between the spec and how the data is actually transferred from the master to a different MQTT client via an MQTT broker. If you have followed the previous videos, you know how to set up a connection to a MQTT broker, especially Mosquitto or AWS IoT Core. Sparkplug is not broker dependent, so it will connect the IO-Link master's MQTT client to any broker. Now with that, let's continue with our previous Mosquitto configuration.
So let's get started with Sparkplug configuration this time. So first thing first, I'm on the web interface of our IO-Link master with the IP address which is related to the IO-Link master. The second thing which we require is under the configuration tab, go to MQTT, and we'll see a bunch of settings that appear. Very easy to set it up. Just click on edit. First thing first, you have to enable the MQTT client. I've done that. By default, the message structure is set on JSON MQTT. That's the vanilla MQTT specification. In this case, I'm going to select Sparkplug as we are working with Sparkplug. That's the IP address of my Mosquitto broker. It's non-encrypted, so we are using 1883. Rest of the options are for either you want to use encryption or username or password. Client ID is not relevant for Sparkplug, so we are going to go further down. The quality of service is 0. Mostly it's kept 0, but if you want to have quality of service 1 or 2, you can have those 2. The only difference is that these make sure that the message is delivered, but also increases the latency because of the handshakes. Now, going further, we don't require topic-based path for Sparkplug, but we do require a group name and a node name. So in this case, I've given a group name PF Toronto and a node name SB Home Office because I have different masters at my home and at my office. So I have given them different node names. We don't allow illegal characters on matter for Sparkplug B. We can have the client publish rate. That's fine. ISD write, because we do want to write ISDU in the future, so we can keep this enabled. Sparkplug B already comes with a timestamp, so we don't require these options. So I'm just going to click on save. And if everything's good, under the diagnostics, we should see a connection appear. So let's refresh the page and we can see it's enabled and the client state is connected. That's good. Oh, one thing we can take a look at is these filtering options. So over here on the bottom, we can already see that this is being filtered. These have been parsed by the IOTT files. I'm just going to copy this, future reference, but we can also test quickly. I have this another client that's called MQTT-FX, and I've connected to my broker, which we also connected our link master to, and I'm already subscribed to it. Right now, we don't see any messages appearing because my ultrasonic distance sensor is stable on a single location, but as I start moving it, we should see the flow of message coming in. Over here, we can also see that the format of the message structure. So it's SPB, Sparkplug B version 1.0, then we have Toronto. So group ID, the data, and then node ID, and /1 is the device itself, the port itself, that's port 1. And over here we can view metrics coming in, so that's distance. And then we have our switching signals and stuff. One thing to notice is the payload decoder. Over here we are using a Sparkplug B decoder. In case you are using a client which doesn't have Sparkplug B, it's going to look something like this. It's going to just give you invalid data and will make no sense. So your client support for Sparkplug B is really important in this scenario. With that, we can also take it one step further. If we go back to our settings, we can use the Sparkplug B filter options, in which we can mention the filter field, which we copied earlier for distance. And we can say that how much change should occur before we see a spike and we see the data being published. So we can actually give it an absolute plus minus or a percentage. Let's give it an absolute of 10.0. Let's save it. And if we observed over here, my data, even if I'm moving the ultrasonic sensor a bit, it's not populating. But as soon as I move my ultrasonic sensor more than 10 millimeters, we see your data coming in. So that really helps in controlling how much data you want being passed by the broker at the end, which is going to save you a lot of cost if you're using a broker that's online. So with that, we are good on the demo side.
That's how easy it is to get your iLink Master, ICE2 and ICE3 talking Sparkplug B in no time. Thank you for watching. Like and subscribe. Bye.